This is a work solution for Mechanical Science, Sheet 7, Question 1. So we've been told that we have a cricketer who tosses a ball straight upwards with initial speed of 12 meters per second, and we're ignoring air resistance, and we're told to figure out how long it takes the ball to reach its highest point. So basically, if we take this equation that we've used before and think about the final velocity being 0, because at the highest point it's going to stop going up any higher, so its vertical velocity is going to be 0. And we know its initial velocity is 12 meters per second, so we can plug that into that equation and rearrange to find t. And also our acceleration is gravity, but it's like acting against our velocity, so it's negative g. And we can rearrange to get this. So t is equal to u over a, and our a is negative g, and we should get a time. The second part of the question asks how high the ball goes. So if we use this equation instead now, v squared is equal to u squared plus 2as, and we plug in our same values for the final velocity being 0, our initial velocity being 12, and our acceleration being negative g, we can rearrange to find s. The final part of the question is slightly trickier. It asks us to find, it asks us to find the amount of time it takes the ball to reach 5 meters above the person who throws it. So we use this equation again, s equals ut plus half at squared, but I've got u in brackets and half a in brackets because these are basically coefficients to the variable t, and basically that to solve this problem we need to use the quadratic equation. So basically we can rearrange it like this, and that will give us a value for t. So it's negative u plus or minus the square root of u squared minus 4s multiplied by a over 2 divided by 2a over 2. If you Google the quadratic equation, you'll sort of see how it's meant to look, and then you'll sort of get an idea of why we've got a over 2 as a coefficient rather than just a.